Welcome back to Shital's Data Desk, your go to space for learning data and analytics in clear, practical, and simplified way. Behind every dashboard lies a process. Have you ever thought about how that data becomes insight? Well, this video is exactly what you need. We are diving into four main types of data analysis, foundation of every analytical project. Data is everywhere, from your online shopping trends to hospital patient records. But here's the truth: data itself isn't powerful, it is what you do with it that creates value. In this video, we will explore each type of data analysis step by step, like what it means, how it works, and real world examples from business, science, and even everyday life. By the end of this session, you will not only understand each analysis type but also know which one to apply when and why. So, let's dive in and start transforming data into insights. Let's start with simplest and most common type, descriptive analysis. This is all about summarizing what has already happened using historical data. It doesn't predict or explain, it simply describes the past. Descriptive analysis uses two key methods, data aggregation and data mining, to uncover patterns and trends in existing data. In simple terms, it is like reading summary after watching movie. No new scenes, just what's already happened. Goal here is not to make predictions or draw inferences, but to represent facts clearly and accurately, helping you answer one key question: what happened? Businesses use descriptive analytics all the time. Company tracking monthly sales trend, YouTubers reviewing total views and new subscribers, or hospital analyzing number of patients admitted per day. These all summarize historical performance without explaining why things happen. Tools like Excel, Power BI, or Tableau make descriptive analytics easy to perform. You can visualize data using bar charts, line charts, or pie charts, and create dashboards that show metrics like revenue, customer satisfaction, or website visits. Even platforms like Google Analytics or social media insights use descriptive analytics, summarizing clicks, likes, and engagement counts. In most organizations, descriptive analytics forms foundation of everyday reporting. Think of annual revenue reports, inventory summaries, or sales dashboards. All are examples of descriptive analysis providing clear snapshot of company operations. However, while descriptive data helps spot trends and patterns quickly, it has its limitations. On its own, it doesn't explain why those trends occur or what might happen next. To gain deeper insights, you will need to go beyond into diagnostic, predictive, or prescriptive analysis. So, whenever your goal is to summarize historical data and present facts clearly, you are doing descriptive analysis, foundation of all other types of analytics. Now that we know what happened, next logical question is why did it happen? This brings us to the second type of analysis, diagnostic analysis. It's all about digging deeper to uncover causes, relationships, and patterns that explain why behind the numbers. While descriptive analysis gives you summary of past events, diagnostic analysis focuses on finding reason behind them. It is the difference between reading report and actually investigating story behind it. Let's take simple example. Restaurant notices that sales dropped last month. Descriptive analysis shows decline, but diagnostic analysis asks why. Was it because of bad weather, new competitor, price change, or poor online reviews? Diagnostic analysis helps uncover these root causes. To perform diagnostic analysis, we often use methods like comparing time periods, for instance, checking sales this month versus last month, filtering data by region, product, or customer segment, correlation analysis to identify a relationship between variables, statistical testing like t-test or regression to verify if changes are significant. In tools like Excel or Power BI, diagnostic analysis can be done using filters, slicers, and trend comparison visuals. In SQL, you can write queries to compare different branches or time periods. For more advanced analysis, Python and R can be used to perform correlation or regression testing. Here's another example. An e-commerce company sees sudden drop in website traffic. Diagnostic analysis might reveal that it coincided with change in Google's research algorithm, or perhaps the marketing team paused ad campaigns. By pinpointing why it happened, company can take corrective action quickly. Diagnostic analysis is often represented with cause and effect diagrams, comparison dashboards, or heat maps showing performance differences across categories. These visuals make it easy to connect actions with outcomes and tells deeper story hidden beneath surface data. In simple terms, descriptive analysis tells you what happened, and diagnostic analysis explains why it happened. Together, they form foundation of every data-driven investigation because knowing what without why is like reading results without context. So, whenever you see unexpected change in sales, views, or performance, don't just describe it. Dive deeper, ask why, and use diagnostic analysis to uncover real story behind your data. Now that we understand what's happened and why, next logical question is what could happen next? That's where predictive analysis comes in. Predictive analytics is advanced method of data analysis that uses historical data, statistical models and machine learning to forecast future outcomes. In simple words, it helps us make educated guesses about future based on what we already know from the past. It works by identifying patterns and relationships in existing data and using them to calculate probabilities of what might happen next. Just like weather forecast, which analyzes years of past data to predict tomorrow's temperature. Think of Netflix predicting what you will watch next based on your viewing history, or e-commerce site recommending products based on your previous purchases. These are classic examples of predictive analytics in action. Businesses use predictive analytics to forecast sales for upcoming quarters, predict customer churn who is likely to stop using their service, estimate product demand, and even prevent fraud by recognizing unusual behavior patterns. Behind scene, predictive analytics combines data mining, statistical modeling, and machine learning. Algorithms analyze past data and fill in missing information with most likely outcomes, turning uncertainty into probabilities. More advanced branch of predictive analytics is deep learning, which mimics human decision making through neural networks. For instance, in finance, deep learning can predict credit scores more accurately by considering multiple social and environmental factors. In healthcare, it can analyze MRI scan and X-rays to help doctors detect diseases early. Most popular tools for predictive analytics include Python with libraries like Pandas, Scikit-learn, and TensorFlow, as well as R and even Power BI, which now includes built-in forecasting capabilities. But remember, predictive models are not magic. Their accuracy depends entirely on quality and volume of data you feed them. As saying goes, garbage in, garbage out. So, clean, reliable data is critical for trustworthy predictions. To sum it up, predictive analysis doesn't promise certainty, it provides probabilities. It helps businesses, scientists, and even creators make informed decisions today by learning from patterns of yesterday. Finally, we reach most advanced and actionable stage of analytics, prescriptive analysis. If predictive analysis tells you what could happen, prescriptive analysis tells you what you should do about it. Prescriptive analytics combines mathematics, statistics, computer science, and machine learning to go beyond insights and directly recommend best course of action. It's like having digital advisor that doesn't just describe or predict outcomes but also tells you optimal next move. It gathers data from both descriptive and predictive models, runs simulations, tests multiple decision paths, and evaluates how each choice might affect outcome. In short, it helps businesses ask if we take this action, what will happen and what's the best option. For example, airlines use prescriptive analytics not just to predict flight delays but also to recommend how to reschedule passengers in most efficient way, saving both time and customer satisfaction. Healthcare providers use it to recommend best treatment plans for patients based on medical history and predictive risk factors. Meanwhile, financial institutions use prescriptive models to decide how much to lower prices or adjust credit limits to attract new customers without hurting profitability. Power of prescriptive analytics lies in its ability to simulate multiple future scenarios, measure consequences, and then recommend best course of action to achieve goals. This saves both time and money while delivering optimal business results. Prescriptive models often use machine learning, optimization algorithms, simulations, and sometimes even AI driven decision engines. In tools like Python, libraries such as TensorFlow and PyTorch are used, while enterprise tools like Power BI with AI integration and IBM Watson Studio are becoming increasingly popular. Imagine supply chain system that not only forecast when inventory will run low, but automatically reorder stock from base supplier at right price without human intervention. That's prescriptive analysis in action, turning data into direct decisions. In summary, prescriptive analytics represent future of business intelligence. It doesn't just explain or predict, it guides action, helping organizations make faster, smarter, and more confident decisions driven entirely by data. There is one more type that doesn't always get mentioned: exploratory analysis. This is when analyst explores data sets freely to uncover unexpected insights without predefined questions. It's creative, curious, and often the first step in discovering new patterns. Example: marketing analyst might discover that customers who buy product A often return to buy product B, even though team never asked that question initially. To wrap this up, let's revisit four types of data analysis and what they help us uncover. Descriptive: what happened? Diagnostic: why did it happen? Predictive: what might happen next? Prescriptive: what should we do about it? Each type builds on previous one. You start with describing, then diagnosing, predicting, and then finally prescribing. Remember, you don't need AI for every problem. Even Excel or Power BI can help you move from descriptive to diagnostic effectively. So next time you look at your data, ask yourself, am I describing, diagnosing, predicting, or prescribing? That's how you will know which tool and techniques to use. If you found this video helpful, make sure to like, share, and subscribe for more videos on data analytics and visualization. And here's question for you. If you had sales data from past 3 years, what's first thing you would analyze? Trends, reasons, or predictions? Drop your answer in comments below. Thank you for watching.